Let me begin with a question that sounds almost innocent. Why haven't we visited the stars? Not in movies, not in novels, not in dreams. In reality, we have smartphones that fit in our pockets and machines that can see galaxies billions of light years away. We've walked on the moon, we've sent robots to Mars, we've touched the edge of our solar system with small metallic ambassadors drifting in the dark. So why haven't we gone farther, Five or Civ? Why aren't there human footprints on planets orbiting other stars? Is it just a matter of better engines, more funding, more courage? Or is there something deeper? Something built into the structure of the universe itself that quietly says, this far and no farther. Tonight I want to think out loud with you about the physics that makes interstellar travel not just difficult, but perhaps fundamentally impossible. And I say perhaps very carefully, because one of the most honest things we can say in science is we don't know everything, but we do know enough to see the shape of the cage we're in. Let's start with something simple. The nearest star beyond our sun is about 4 light years away. That sounds small. 4, just 4. But what does that mean? A light year is the distance light travels in 1 year. And light is fast. Unimaginably fast. It circles the Earth 7 times in a single second. It travels from the moon to us in a little over a second. From the sun in about 8 minutes. Light is the universe's speed champion. So when we say 4 light years, we're saying even light, the fastest thing there is, takes 4 years to get there. Now imagine you're in a car driving down a highway. You can go maybe 100 kilometers per hour. That feels fast. The landscape blurs, the wind roars. But compared to light, that speed is nothing. It's like a snail compared to a lightning bolt. Our fastest spacecraft, after decades of engineering brilliance, crawl through space compared to light. If you could ride one of them toward the nearest star, you wouldn't arrive in 4 years. You wouldn't arrive in 40 years. You would arrive in tens of thousands of years. That's longer than recorded human history. So the first problem is distance. Space is not just big, it is absurdly big. Offensively big. The kind of big that makes your brain want to shut down and say, I don't accept this. But distance alone doesn't make something impossible. It just makes it hard. The deeper problem is speed. There is a limit in the universe. A speed limit. Not like a highway sign you can ignore if you're reckless enough. A fundamental limit. A built-in rule. Nothing with mass can reach the speed of light. Not almost anything. Nothing. And the closer you try to get to that speed, the harder it becomes. It's like pushing a car that gets heavier the faster it goes. You push harder, it resists more. You push even harder, it resists even more. As you approach the speed of light, the energy required doesn't just increase, it explodes upward. It becomes absurd. Infinite, in fact, at the limit. It's as if nature is saying, you can approach the door, you can look at it, but you cannot pass through. Now think about what that means. If you want to reach a star in a reasonable human lifetime, say a few decades, you would need to travel close to light speed. There's no other way. The stars are too far. But getting close to light speed requires enormous energy. And not just a little more than what we have. Not 10 times more. Not 100 times more. Staggeringly more. Where would that energy come from? You imagine trying to accelerate a small spacecraft to near light speed. You would need fuel. But fuel has mass. And mass makes acceleration harder. So you need more fuel to accelerate the fuel. And then more fuel to accelerate that fuel. It becomes a cruel spiral. You end up carrying so much fuel that you need even more fuel just to move it. It's like trying to run a marathon while carrying all the food you'll eat during the marathon on your back, and then realizing the food itself is so heavy that you need even more food to carry it. At some point, the numbers stop being engineering challenges and start becoming cosmic jokes. But let's say somehow you solve the energy problem. Let's imagine a miracle engine. Something beyond anything we know today. There's another problem waiting. Time. When you move very fast, something strange happens. Time for you slows down compared to those who stay behind. This is not science fiction, it has been measured. Clocks on fast airplanes tick differently than clocks on the ground. Tiny differences, yes, but real. So you might think, if I travel near light speed, maybe I can reach a star within my lifetime. Because time slows down for me. That you'd be right. In a sense. From your perspective, the trip might feel shorter, but from Earth's perspective, years or centuries may pass. You could leave your home at age 30, travel to a distant star, turn around, and return only to find that everyone you knew has been dead for generations. Interstellar travel becomes not just a journey through space, but a one-way leap into the future. Are we ready for that? Are we emotionally built for that? Are we emotionally built for that? Vutted. And even if we are, there's still more. Space is not empty in the way we casually say it's empty. It contains particles, dust, radiation, tiny bits of matter drifting in the dark. At everyday speeds, those particles are harmless. But at speeds close to light, even a speck of dust becomes a bullet. A grain of sand becomes a bomb. Imagine driving through a fog of microscopic debris at nearly the speed of light. Each impact releases enormous energy. Your spacecraft would need shielding so thick and strong that it adds even more mass, which requires even more energy to accelerate, so the universe does not make it easy. And then there's radiation, high-energy particles streaming through space. At high speeds, they become even more dangerous, slamming into your ship with intensified force. Your interstellar vessel becomes less like a cruise ship and more like a bunker racing through a shooting gallery. So far, we have distance, speed limits, energy demands, time distortion, radiation, and debris. And we haven't even talked about life support. Humans are fragile. We need air, water, food, temperature control. We need psychological stability. We need community. Can you imagine living in a metal cylinder for decades? Generations, perhaps? Children born on a ship who never see a planet until adulthood. Interstellar travel may not be a trip. It may be a civilization sealed inside a moving world. And that moving world must survive perfectly for centuries. No catastrophic failure. No critical breakdown. No irreversible mistake. Do you trust any machine to work flawlessly for 300 years? Now let's step back. It's tempting to say technology will solve it, we just need time. But physics is not impressed by optimism, not. Physics does not negotiate. You cannot vote to repeal the speed of light. You cannot petition the universe to make energy cheaper. You cannot persuade radiation to be gentle. These limits are not political. They are structural. They are woven into the fabric of reality. And that is the unsettling part. We like to think that with enough intelligence and determination, anything is possible. But physics whispers something humbling. Not everything is possible. There are walls. Not because we lack courage, but because the universe has rules. And those rules might confine us to our cosmic neighborhood. Now, some people will say, what about bending space? What about shortcuts? What about wormholes? Ah, yes. The dream of folding space like paper. But even those ideas, as beautiful as they are, come with severe problems. They require forms of matter and energy we have never seen. They may demand conditions that cannot exist naturally, Zat. It's like designing a bridge that requires a material stronger than anything in the universe. It's a lovely sketch, but where do you find the substance to build it? So perhaps the real lesson is this. The universe is not a playground designed for unlimited exploration. It is vast beyond comprehension, and yet tightly constrained. We can see billions of galaxies. We can detect signals from the edge of the observable universe. But reaching even the nearest star may lie forever beyond our physical reach. Does that make the universe cruel alive, or does it make it profound? Because here's the twist. The same physics that prevents us from racing freely among the stars is the physics that makes stars shine. It's the physics that holds atoms together. It's the physics that allows chemistry, biology, consciousness. The speed limit of light is not just a barrier. It's part of the architecture that makes stable reality possible. If there were no limit, cause and effect could break down. Signals could outrun their consequences. The universe might become chaotic, unpredictable in a deeper way. The very rule that traps us may also protect coherence. Not so maybe interstellar travel is impossible not because the universe is stingy, but because the universe is consistent. And consistency has consequences. Now here's a philosophical question. If we are confined to our tiny corner of the galaxy, what does that say about ambition? Does it shrink us, or does it focus us? Maybe our destiny is not to scatter physically across the stars. Maybe it is to understand them. We have already reached distant galaxies with our minds. We have decoded starlight. We have reconstructed the history of the cosmos from faint whispers of radiation. We may never walk on an exoplanet, but we can know its atmosphere, its temperature, its composition. We can know, not there is something extraordinary about that. A small species on a small planet, orbiting an ordinary star, has figured out the rules of the cosmos well enough to understand its own limitations. That is not failure. That is triumph. Perhaps the impossibility of interstellar travel is not a sentence. Perhaps it is a frame. A frame that reminds us how precious this planet is. If we cannot easily leave, then this world is not a temporary campsite, it is home. And maybe the physics that binds us here is an invitation to care for it more deeply, to explore inward as much as outward, to recognize that infinity does not require physical travel, because infinity already surrounds us in understanding. So I leave you with this thought. The stars may be unreachable in body, but they are not unreachable in mind. The same laws that prevent us from crossing the cosmic ocean have allowed us to comprehend it. And maybe that is the deeper miracle. We are made of the same matter as the stars, bound by the same rules, limited by the same speed, yet somehow, within those limits, awareness has arisen. Awareness capable of asking, why can't we go farther? And that question itself, that restless curiosity, may be our true form of interstellar travel, not through space, but through understanding. The universe has drawn a boundary, but inside that boundary, it has given us something extraordinary. The ability to know we are bounded, and to wonder anyway. Let's go a little deeper, because sometimes when we hear that something is impossible, we secretly think it just means not yet. Human beings have a long history of turning impossible into ordinary. Flying was impossible. Crossing oceans was impossible. Reaching the moon was impossible. So maybe interstellar travel is just the next mountain waiting to be climbed. But there's a difference between a mountain and the horizon. A mountain is high, difficult, dangerous, but it is still inside the landscape. The horizon is not a place you can reach. It's a limit built into the geometry of how you see. The speed of light is not a mountain. It's a horizon. And the closer you run toward it, the more it recedes as a reachable destination. You can spend more and more energy. You can design smarter engines. You can push harder. And nature will simply respond by making it harder still. It's almost playful. It says, you want to go faster? Fine. I will make you heavier. You want to go even faster? I will stretch time. You want to reach the ultimate speed? I will demand infinite energy. Infinite. That word should make us pause. In engineering, we talk about large numbers. In economics, we talk about big budgets. But in physics, when something requires infinite energy, that's not a practical obstacle. That's a logical wall. It's like trying to divide something into smaller and smaller pieces and eventually discovering you've reached the smallest possible unit. You cannot go beyond it because beyond has no meaning. Now here's something subtle and fascinating. The universe does not just limit our speed, it also limits our communication. Even if we sent a probe toward a distant star, any message it sends back can travel no faster than light. So if it reaches a star 10 light years away, we won't know what it found for 10 years after it sends the message. Interstellar exploration becomes an exercise in patience measured in decades or centuries. Civilizations will not need to think on timescales longer than individual human lives. Are we built for that? Our political systems struggle with 5-year plans. Our attention spans struggle with 5-minute videos. Interstellar travel demands 500-year commitments. And this brings up something that isn't purely physical but still deeply tied to physics. Stability. The universe may allow slow travel between stars. Very slow travel. But the timescales involved are so long that the survival of the travelers becomes the real challenge. A spacecraft traveling for hundreds or thousands of years would need to function as a self-contained ecosystem. It would need agriculture, recycling, social structures, education systems. It would need to handle births, deaths, conflicts, cultural shifts. It would no longer be a vehicle. It would be a world. And that world would be moving through a vacuum colder and darker than anything on Earth, exposed to radiation, micrometeoroids, and mechanical wear. One small failure in year 372 could doom generations. Physics doesn't just challenge our engines, it challenges our psychology and our sociology. Now let's consider another idea people often raise. What if we send machines instead of humans? That seems more realistic. Machines don't need air. They don't get lonely. They can endure radiation better than fragile biological tissue, and indeed, we have already sent machines farther than any human has gone. Tiny robotic explorers drifting beyond the planets. But even machines face the same speed limit, the same energy problem, the same cosmic distances. A robotic probe traveling at our current fastest speeds would take tens of thousands of years to reach even the nearest star. By the time it arrives, the civilization that launched it no longer exists. Imagine building a cathedral that will only be seen by people 10,000 years from now. Would we do that, Devire? Would we even remember why we started? And here's another twist that feels almost poetic. Because of the finite speed of light, when we look at distant stars, we are seeing them as they were years ago. When we look at distant galaxies, we are seeing them millions or billions of years in the past. In a sense, we are already traveling through time just by observing. Our telescopes are time machines. But they are one-way time machines. They bring the past to us. They do not carry us into the future of distant worlds. And this reveals something profound. The universe is structured in such a way that knowledge travels more easily than matter. Light can cross interstellar space in years. Information can ride on that light. But bodies, ships, civilizations, they are heavy, they are slow, they are bound. It's as if reality favors awareness over expansion. You can know the stars more easily than you can touch them. Now pause for a moment and feel what that means. We are creatures with dreams of infinite exploration. We write stories about galactic empires and starships jumping effortlessly between solar systems. And yet, the quiet truth of physics suggests that the galaxy may never be a network of bustling civilizations. It may remain mostly silent, mostly isolated. Perhaps each star system is its own island, separated by oceans so vast and so resistant that crossing them is not part of the cosmic plan. This might even help explain something people often wonder about. If the universe is so old and so large, and if life can arise, then where is everyone? Where are the alien visitors? One simple answer might be, they are bound by thought, the same physics we are. They look at the stars and see the same horizon. They calculate the same energy requirements. They confront the same speed limit. And they realize that interstellar empires may be dreams, not destinations. Now, I don't say this to crush imagination. Imagination is precious. It pushes us to explore, to question, to invent. But imagination must dance with reality. The rhythm of limits, the rhythm of conservation, the rhythm of cause and effect moving no faster than light. Sometimes we think limits are signs of weakness. But in physics, limits are often signs of structure. The speed limit of light is what keeps cause before effect. It's what prevents paradoxes from tearing logic apart. It's what allows events to unfold in a consistent order. Without that limit, the universe might not be intelligible at all. So the same rule that prevents us from hopping between stars may also be the rule that allows us to understand anything in the first place. And here's something that humbles me every time I think about it. We evolved on a small planet. Our brains developed to throw spears, recognize faces, find food. Nothing in our evolutionary history required us to understand cosmic speed limits or energy scales. And yet, through careful thought and experiment, we have uncovered these deep constraints. We have discovered that the universe has a maximum speed. We have discovered that energy and mass are deeply connected. We have discovered that time itself bends and stretches with motion. We didn't guess these things correctly by instinct. We learned them by being willing to let go of comfortable assumptions. And that, perhaps, is the most important lesson of all. Interstellar travel may be impossible not because not begins, but because we finally understand enough to see the boundaries. And understanding boundaries is a sign of maturity. A child believes anything is possible. An adult learns that possibility lives inside structure. The universe is not an open field without fences. It is a vast landscape with contours and edges, and we are learning to read the map. Now, does this mean we should stop dreaming of the stars? Absolutely not. We should study exoplanets. We should build better telescopes, better probes, better models. We should push against the limits to understand them more clearly. But we should also cultivate a different kind of awe, not the awe of conquest, the awe of comprehension. There is something deeply beautiful about a universe that is both immense and lawful. A universe where the same simple rules apply everywhere. A universe where the same speed limit governs the flight of light from distant galaxies and the signals inside your phone. The stars may remain physically distant, but intellectually they are already within us. Every atom in your body was forged in a star. The calcium in your bones, the iron in your blood, born in stellar furnaces long before Earth existed. In that sense, we are already interstellar. We are made of star matter contemplating stars. And perhaps that is the universe's most elegant solution. Instead of sending bodies across impossible distances, it built beings who could understand distance. Instead of granting us unlimited travel, it granted us insight. And insight, when you really think about it, might be the more powerful form of exploration. So maybe the physics that makes interstellar travel impossible is not a prison. Maybe it is a teacher. It teaches us humility. It teaches us patience. It teaches us to value the fragile world we inhabit. And it teaches us that some frontiers are not meant to be crossed physically, but mentally. The question is not whether we can break the cosmic speed limit. The question is whether we can fully appreciate the extraordinary fact that we discovered it at all. We are small. You see, we are bounded. We are confined to a tiny corner of one galaxy among billions. And yet we have figured out why we are confined. That may be the greatest journey we will ever take. Not from star to star, but from ignorance to understanding. And that journey, unlike interstellar travel, is not only possible, it has already begun.